Once again, we're turning to my trusted laptop to give you a taste for what running HDFS into the distributed mode would look like. Let's start with configuration files. Now, to save some time on typing, I basically have copies of the right ones in my TMP folder. So let's put them where they belong, which is underneath the Hadoop home in Hadoop's configuration folder. And just to make sure that we got the right stuff in, let's take a look at the core site first. So as you can see, it contains just a single configuration property, which is telling HDFS name node on which port to run. And it also tells the data nodes, to where to connect to. And now let's take a look at the other one, so HDFS site. And again, as you can see, it's just a single configuration option, DFS replication, which basically lowers down the number of replicated blocks needed for each file to 1. Because we're running on a single node, we cannot really replicate blocks to any other nodes here. So now that we have the files in place, next step up is to format the name node. This is the same step that you would do with a brand new hard drive, to basically put a new file system on it. So let's run the format command, and we will use the HDFS command line utility. We will give it a name node option, and then to the name node option, we will give -format as a sub option to format the HDFS. So let's run it. That was a lot of output. In fact, when running the services, let's actually make sure that this kind of logging goes to files instead of to our terminal window. We will use shell redirection for that, and I will explain how it goes. And we will also try to use shell to basically run the services in the background so they don't mess up our terminal window. So the first service to run is the name node itself. So let's actually try running it. And again, we're using the HDFS CLI command. And if you just give it a name node subcommand, what it will do, it will start up a name node daemon. Now we're redirecting the output to name node.log, and we're also running it in the background. So let's do this. Okay, so now if you run jobs, which is a shell command showing you what processes are running on your system, you could see that HDFS name node is running. And next thing up is for us to start a data node. So let's do that. So here's a command. And as you can see, it's exactly the same as the command for the name node. The only difference being that we're starting a data node and we're redirecting to a different log file. So again, let's run it. And just to make sure that everything is up and running, let's run jobs once again. And you could see that now you have 2 processes running, one for HDFS name node and one for HDFS data node. Okay, so everything seems to be up and running. So let's actually create our input folder, just like we did for Hadoop local mode. In fact, unlike we did for Hadoop local mode, I would actually give it an extra option, -p. And that is why I need it here. Basically, I'm telling mkdir to create all of the path names in front of the input because the content of HDFS is empty at this point. Now, if you don't quite understand why I'm doing this, let's actually list everything that HDFS has at this point. The command for that would be dfs lsr, and if we give it /, it will basically traverse everything that's rooted at /, which is everything, and print out the names of folders and files. Now, don't worry, because we're running a brand new file system. There's only a few lines of output that we expect. So let's run it. So as you can see, giving -p to mkdir created /user, and then it created /user/shopper, and then it created the input folder. So now it's time to put our input file into the input folder. And interesting thing is that we're just reusing the same command that we used for the Hadoop local mode. Just like I promised you, there is absolutely no difference to the command of whether you're running Hadoop in local mode, to the distributed mode, or fully distributed mode. So let's run our put command. So this is our put command, just like we did before. Let's run it here. And the file is now in HDFS. What's next? Well, we can actually try running MapReduce on the file that's in HDFS. And if this sounds a little bit crazy to you, it actually should, because we haven't really configured yarn yet, so there is absolutely no way for us to run MapReduce the way it's supposed to be run, which is on yarn. So we actually will be running MapReduce in local mode, but the data that the MapReduce will take will be actually coming from a real HDFS instance. So let's run this command. This is the same command that we used before, and we're not changing anything. We're just basically running it as it is. So let's try it. And Hadoop kicks in, and it basically works, and it produces the output. This is actually kind of amazing, because if you think about it, the flexibility of Hadoop at this point allowed you to use local MapReduce with fully distributed HDFS. Now, is there any reason to do that? Probably not, but it works, and it's a great testament to how flexible Hadoop is. One last thing that I would like to show you about HDFS is that just like Spark that we've seen before, it actually comes with a nice UI. So that UI is available to you at localhost, since we're running into the distributed mode, at the port number 50070. So if we navigate to this URL, you will basically see a lot of statistics that the name node is telling you. So for example, you can see how many data nodes are attached to a name node. What's also interesting, you can actually browse the file system. So right here, we see our user subdirectory. So let's click on it. Then we see a single subdirectory underneath that. Let's click on that. And then there are our input and outputs, just like you would expect after running a MapReduce. So let's click on output. And if you click on this file, you will actually see statistics about it. And you can download it, and it would look exactly like the file that we got from MapReduce when running it in local mode.